Hi, today we're going to be talking about 3.7 implicit differentiation. If you notice, we got the black background in honor of tonight's blackout with the homecoming football game. So I'm just assuming you guys are winning by a lot right now for your homecoming game. So go Eagles. Anyway, we're going to be talking about implicit differentiation. Again, finding tangents and normals of these relationships, higher order derivatives, and the power rule with all rational powers, meaning we don't just have to have integer values for our powers. Using the power rule now, we can have irrational numbers, rational numbers such as fractions for our powers. So we'll find that useful. Okay, the point of implicit differentiation is finding the slope of relationships like this circle. Like if we were to draw this circle here, I would draw it as a circle with a radius of 4. So that would be there. That's not a function. So in order to solve for this, we have to be able to differentiate this in terms of x, but differentiate y as well. So in order to do that, we just need to think about a couple things. When we are finding the derivative, we usually say, okay, dy or d dx is how we write the derivative of something. So we're going to find d dx of all of this. But when we do this in terms of y, right, well, let's just do one and see what happens. Let me get rid of this. So the derivative of x squared is 2x, alright, and it's really dx over dx, but those two go away and they cancel. Okay, so when we're differentiating implicitly, you have to have that as like the extra step there that you're probably not used to. Okay, so usually that cancels and goes away to 1. Plus, we now have to differentiate the y. So it is 2y dy over dx. Now that doesn't cancel. Okay, so that's what we're trying to find. We're going to end up having to solve this for dy dx equals 0. Now let me just rewrite it as 2x. Now the dx over dx cancels to 1, plus 2y dy over dx. So now we need to find, we need to solve for dy dx. So move that. Let's try this. Move that 2x over to the other side. And then we'll divide the 2y over here in a second. 2y dy dx equals negative 2x. So then dy over dx equals negative 2x over 2y, which equals negative x over y. So the slope equation, so this is nice because we can now, if we had a point and we wanted to plug it in, like let's say I wanted to know what is the slope at that point up there, which would be at 0, 1. I could just plug this in, and this would give me a 0 over 1, which equals 0, and that should be 0 because the tangent line at the top of the circle is 0. Okay, why don't you guys try one? Find dy dx using this equation. Solve for y. Well, this one's kind of hard actually. I'm going to do it. So you sit back and relax and take some good notes. So the derivative of x cubed is 3x squared, And then remember, it is that dx over dx, but I'm not going to write that anymore because we know that equals 1. Plus 3y squared, what we do with the y is have to write dy dx, okay, equals, all right, 18 times, okay, first times the derivative of the second, well, that's just dy over dx, plus second times the derivative of the first, which is just 1, dx over dx is just 1. Okay, now we need to figure out, alright, I should distribute this 18 over here. 18x dy dx plus 18y. Alright, now I need to get my dy dx's together, so I'm going to rewrite the equation to have my dy dx's on the left side, so it will be 3y squared dy dx minus 18x dy dx equals 18y minus 3x squared. So hopefully you can follow that algebra. If not, hit pause and see if you can figure out how I did that. Now I need to factor out the dy dx from both of these terms, so I write it as dy over dx times 3y squared minus 18x equals 18y minus 3x squared. Okay, so now to solve for dy dx, I just divide both sides by this 3y squared minus 18x. 3y squared minus 18x. So my final answer, dy dx, is equal to 18y minus 3x squared over 3y squared minus 18x. Now remember, the whole point of this is to take these relationships that are not functions and be able to find the slope somewhere along the relationship given some x and y value. You will see all of these have x's, and well, most of them will have x's and y's in their derivative or their slope equation. So let's get a little bit more specific and talk about what is the line that is tangent to x squared plus y squared equals 25, so the circle with a radius of 5, at the point 3, negative 4. So let's take a look. Let's just draw that really quick so we can see what we're talking about. There's our circle. Okay, it's got a radius of 5. Okay, and 3, negative 4 would be about here on the circle. And that makes a 3, 4, 5 triangle if you were to do that, so it does hit the outer edge of the circle. Just as a good check. Okay, first thing we need to do to find a tangent, remember we need to find the slope equation. So let's implicitly derive this relationship. So we get 2x plus 2y dy dx equals 0. Remember, when you're implicitly differentiating with y, you have to have that dy dx there with it. The 2x has a dx with it, but that just cancels to 1. Okay, so don't forget that. Now, if we solve this for dy dx, we get, move that 2x over, that's negative 2x over 2y, which is equal to negative x over y. Same thing we got when we were doing the circle with a radius of 4. So it's pretty interesting, actually, that you get that same exact equation. Kind of neat, and actually it doesn't matter. You could make this as big as you want, and the ratios will stay the same no matter what it is. So if you're finding the same angle, this 3 comma 4, which will give me a relationship of 3 over 4, will be the same ratio no matter how big the circle. Okay, so this is our slope equation. So now I need to plug in the point to find the slope. So I'll just plug it in. I get -3 over -4, which equals 3/4. So that's my slope. So now I have a point, I have a slope, I can write an equation. Y minus a negative is plus 4 equals 3 over 4 times x minus 3. Okay, and if you wanted to, you can solve that for y, but I'm good there. Now, the line that is normal would just be, so we were just basically finding this tangent line there. Okay, well if we want to find the normal line perpendicular there, we use the opposite reciprocal slope. So it's going to be pretty much the same setup, y plus 4, because that's my y value of the point, equals, but this time it's going to be negative 4/3 x minus 3. So there's our two equations. First one's for the tangent, second one's for the normal line. Okay, I want you to try this. Find the line that's tangent to the curve at the given point, pi over 4, pi over 2. So hit pause, give this a shot, go. Okay, hopefully you realize this one was a little bit harder and you were up for the challenge. But we have a couple things. First, because we've got two functions, well, we kind of have three functions. We have x, we have sine, and then we have 2y inside. So we've got a product rule with a chain rule here, because we've got a function inside a function. Same thing over here. A function of y, function of cosine, and inside a cosine we have 2x. We have another product rule with a chain rule, or composite function there. So, to do this we do first times the derivative of the second. So the derivative of sine is cosine. Okay, derivative of the outside, leave the inside alone, times the derivative of the inside. That would be 2 dy dx. Okay, so first times the derivative of the second, plus second times the derivative of the first, well, derivative of x is just 1, equals first times the derivative of the second. Derivative of cosine is negative, so I'm going to put that in front. Sine of 2, leave the inside alone. Okay, and then derivative of the inside is 2. First times the derivative of the second plus the second times the derivative of the first, which would be dy dx is the derivative of y. Okay, so now I need to move my dy dx's together. I'm also going to kind of simplify some of these. Usually we want our numbers and our x's and y's and our negative signs all in front, so you'll notice that I'll rearrange this just a little bit. So if I move some of these over, I would get x cosine, 2 x, because I move this 2 in front, cosine of 2y dy dx. Okay, I want this now to come over, so I'm going to make it minus cosine of 2x dy dx equals, move everything else to the other side, so I have negative 2y sine of 2x minus sine of 2y. From here, I can factor out a dy dx from both, and then divide over what gets factored out, and it's going to give me, well, I'll factor it out so you can see it better. Dy dx times 2x cosine of 2y minus cosine of 2x equals negative 2y sine of 2x minus sine of 2y. Okay, so divide this over and you get your slope equation to be this really complicated and kind of hard, but at least we have a slope equation so we can find a tangent line and a normal line. Negative 2y sine of 2x minus sine of 2y all over 2x cosine of 2y minus cosine of 2x. There we have it. There's our slope equation. Piece of cake, right? Okay, don't throw anything at me. Let's now find what is the slope at the point pi over 4, comma pi over 2. So let's see, it would be, this equals negative 2 times pi over 2. The 2's cancel, so just negative pi times the sine of 2x. Well, 2 times pi over 4 is pi over 2. If I draw my unit circle, pi over 2 is up here. That's a value of 1. So sine of pi over 2 is just 1. So that just leaves me a negative pi minus the sine of 2y. Well, 2y, 2 times pi over 2 is pi. Sine of pi is 0, so minus 0 over 2 times x. That would give me pi over 2 times the cosine of 2y. Well, 2 times y is just pi. Cosine of pi is 1, so that just becomes 1. So that's just pi over 2 times 1, where's pi over 2, minus cosine of 2x. Well, x is pi over 4. Cosine at pi over 2 then, 2 times pi over 4 is pi over 2, is 0. So this equals, copy dot flip, negative 2. So my slope for this situation, my slope for this situation would be negative 2. Okay, I'm just going to kind of slide this up so I can keep working. So there's my slope. So my point, using my point and my slope to find the tangent line, I do y minus pi over 2 equals negative 2 times x minus pi over 4. Okay, there's my tangent line. My normal line would be y minus pi over 2. The opposite reciprocal of negative 2 is positive 1/2 x minus pi over 4. Okay, so you can distribute and solve for y if you want to. I'm just going to leave it like that though. Now find the second derivative of this. So we're going to do the same thing. We're just going to find the first derivative using implicit differentiation. Then we're going to do it again finding the second derivative using, again, implicit differentiation. So the derivative of y squared is 2y dy dx plus 2 dy dx equals 2 dx over dx is just 1, so 2 times 1 is 2, plus the derivative of any constant is 0, so I can just leave that as 2. Okay, factor out, so I'm going to say this goes to dy dx of 2y plus 2 equals 2. So dy dx is equal to 2 divided by 2y plus 2. So I just divided that over. Okay, there's my first derivative. To find my second derivative, I just do the, now I'll have to use the quotient rule, but just take the derivative of this. So low, 2y plus 2, d high times 0, minus high, d low would be 2, then dy dx, low d high minus high d low, over low low, okay. So that I don't forget what I just did, this was really just solving for d squared y over dx squared. So this is the second derivative. At this point, I already know dy dx over here, so I can just substitute in place of dy dx. So I can rewrite it as the second derivative of y in terms of x is equal to, well, I know that that just cancels to 0, so it's going to be negative 4 times 2 over 2y plus 2. So I just substituted in place of dy dx over here. All over 2y plus 2 squared. Okay, and you can simplify that however you want to simplify it. But that should now give us a second derivative using implicit differentiation. So same thing, take the derivative twice and then you just have to substitute in for that dy dx. We're going to change gears just a little bit and start looking at some of these exponents, looking at the power rule with exponents that aren't integer values. So if we rewrite this as y equals x to the 1/4 power, okay, let's go ahead and find the derivative of this using the power rule. So power rule just says take that exponent, put it in front, so we go y prime equals 1/4 x, and then now we just subtract 1 from 1/4, and we should get negative 3 over 4. Okay, a lot of people want this written without a negative exponent, so if we were to do that, we'd just write it as 1 over 4x to the 3/4, or maybe you'd even write it as 1 over 4 times the 4th root of x cubed. So that might be the way you would want to write it, but you know, probably right there is where I would stop. So go ahead and give this a shot and see how you do. You have a harder one, so I think you can do it. Give it your best shot. You're going to have to use the quotient rule here too. Go. Hit pause. Alright, let's see how you did. So, low d high minus high d low over low low. Low. Well, I need to rewrite this so it makes sense to me. So I'm going to rewrite it as x over x squared plus 1 to the power of 1/2. So, low is x squared plus 1 to the 1/2 power. D high would be 1 minus high d low. Okay, so we need to do 1/2 in front. 1/2 goes in front. Okay, leave the inside alone. X squared plus 1. Okay, and then take the power down by 1. So 1/2 minus 1 is negative 1/2. Okay, now we have to take the derivative of the inside because we've still got a little chain rule going on. We just did the derivative of the outside. Derivative of the inside is 2x. Okay, low d high minus high d low over low low. Well, that cancels nicely with that square root. Okay, so let's rewrite this to be the square root of x squared plus 1 minus 2 times 1/2 is, I'm looking at these values, 1/2 times 2, those go away. The x squared is just, or the x times x is going to give me x squared, okay, times the square root of x squared plus 1 all over x squared plus 1. That's as far as I would take this one. Okay, so implicit differentiation, a little bit harder. I did want to look at maybe one more implicit differentiation and do it in terms of y prime, just so you can see maybe it's easier for you to write it out as y prime when you're solving these. So let me make one up really quick. So I'm going to add this slide here. We're going to find what is y prime if I have the equation 2x y equals maybe something like 1/2 x squared plus 1/3 y cubed. Okay, so I want to know what is y prime equal to. That's what this is asking. Alright, so I'm going to do implicit differentiation, but instead of writing dy dx, I'm going to just write y prime. So this first piece, I have two functions, so I'm going to use the product rule. First, 2x times the derivative of the second is y prime, plus second times the derivative of the first, will just give me 2y, equals, if I use my power rule here, that 2 cancels. I'm just left with x plus y squared times y prime. Okay, so again, instead of writing dy dx, I just wrote y prime. So let me get my y primes together. I'd write it as 2xy prime minus y squared y prime is equal to x minus 2y. Factor out your y primes. So I'm y prime times 2x minus y squared is equal to x minus 2y. Divide by 2x minus y squared. Divide by 2x minus y squared. So y prime equals x minus 2y over 2x minus y squared. So I just wanted to do that just so you can see that maybe simpler for you is to write that y prime versus the dy dx. Bring in lots of questions. Hope you guys had a fantastic football game and that we totally dominated it since it was our homecoming game. I'm sure we did. And let me know what you think about the black background. Thanks.